Okay. All right. So we're going to look at ShearBan, also known as Engo patches, and as it pertains not so much to blisters but to diabetic foot ulcers.
Yeah.
Okay. Well, the things what we're going to do is I'm literally going to almost read from a white paper that was produced by Tamarack Habilitation Technologies back in 2010. I think they've kind of refreshed it. It's because I'm just going to literally sort of read it because it's really well laid out. It's succinct, and I'll just add in a few comments here and there. So we're going to look at the importance of shear in the etiology of diabetic foot ulcers, the principles of shear offloading at locations of high shear loads, offloading shear using traditional methods and using ShearBan, and then we're going to have the case study download that I'm going to provide to you. So this is the white paper. And just as a quick summary, ShearBan is a patented interface material used by clinicians and footwear specialists to prevent and treat diabetic foot ulcers. ShearBan works by offloading shear forces at areas of concern targeted by practitioners. ShearBan complements current pressure offloading techniques. So this is what ShearBan and Engo looks like. It's the exact same product. Engo is more, it's just a brand name they gave to these little patches that are for consumers, for the consumer market, particularly for blister management. And ShearBan now is just available in the sheets. You can get both of these from my website, or you can get them from Brigitte Medical.
Yep.
Two mechanical forces, pressure and shear, cause cumulative trauma to the skin of the foot from repetitive loading. That cumulative trauma is evidenced by erythema, blisters, calluses, and ulcers. Of the two mechanical forces causing cumulative trauma to the foot, shear is the most damaging. This has been recognised by leading experts on the diabetic foot and human skin. So ShearBan is designed to offload shear forces transmitted to the human skin and tissue. Not just the skin, it's all the subcutaneous tissue underneath the skin surface. It does this by reducing friction at high-risk areas on the skin and support devices such as footwear, orthotic or prosthetic devices. Marty Carlson and the product team at Tamarack have spent over a decade developing, testing and refining ShearBan, and it can reduce shear forces by as much as 50%. So ShearBan does this one here. It reduces the coefficient of friction, so it makes it more slippery. It's a slippery surface.
Yep.
What it doesn't do is anything to do with pressure. So when we think about friction force, and friction force are the red arrows here. So when the bone is moving one way, friction force is acting in the opposite direction, and it happens at all the material interfaces. So the shoe floor interface, the sock shoe interface, and the skin sock interface. So Engo or ShearBan will be this middle red arrow. It's working to make it more slippery between the sock and the shoe.
Oh, it's sock and the shoe. Okay.
Yeah, because you stick it to the shoe or the orthotic.
Yep. Okay.
Yeah. So friction force, when we think about friction force, which is the force of stickiness, the grippiness or stickiness between two surfaces.
Yep.
It's determined by both pressure and the coefficient of friction. And we're very good at reducing pressure. We do this with diabetic foot ulcers all the time. But how do we do this at all, and how do we do it? Now, when it comes to blisters, we can use lubricants. We don't really do that with diabetic foot ulcers. It's not practical. We can maybe use armor skin socks when it comes to blisters, but that's not really a good option for diabetic foot ulcers. No. So to my way of thinking, apart from the Armstrong, the silly orthotic device that was made a while ago that I don't really think has caught on in diabetic foot management, there's nothing really that actually addresses the coefficient of friction, to my way of thinking, and I'm by no means an expert, so you may know more than me about that. But it's something to think about when we're trying to reduce friction force. Yes, we can do it with pressure, but we can also do it with the coefficient of friction. The importance of shear in the etiology of diabetic foot ulcers. Leading clinical and research experts have long recognised the importance of friction and shear in causing trauma to the diabetic foot. Paul Brand is perhaps the best known expert to have studied and treated the diabetic foot. Dr. Brand's research and clinical work led to the insight that it is primarily the lack of sensation coupled with the mechanical forces, that was that picture of the foot with all the arrows, that cause the damage to the diabetic foot. Dr. Brand said this about those mechanical forces. There are two types of force which occur on the sole of the foot. One is vertical force at right angles to the foot, so that's like pressure, which causes direct pressure to the tissues. The other is horizontal force or shear stress, which is parallel to the surface of the foot and occurs in association with acceleration and deceleration, i.e. bone movement. Of the two forces, shear stress is the more damaging than pressure. David Armstrong, blah, blah, blah. He's authored hundreds of journal articles, and he said this: it is the equivalent of podiatric dark matter. We believe it's important, but we can't measure it well. In fact, shear stress is probably more important than vertical stress because it occurs twice per step instead of once. At least under the ball of the foot it does.
Yeah.
And then Mettenevers and the guys at Cleveland Clinic have examined the effects of shear forces on the diabetic foot and have attempted to measure it in various ways. They've made these observations. Diabetic foot ulcers are known to have a biomechanical etiology. Among the mechanical factors that cause foot lesions, shear stresses have been either neglected or underestimated. Plantar shear is known to be a factor in callus formation and has previously been associated with high ulcer incidence. During gait, shear stresses are induced with twice the frequency of pressure. And Paul Naylor, back in the 1950s, was one of the first to look closely at blisters. And he said friction applied to the skin may cause either of two main types of reaction. Firstly, if the friction is small in amount but frequently repeated, the skin may react by becoming thicker, that is, callous. Secondly, larger amounts of friction may cause the skin to react by the formation of a blister. Marty Carlson, founder of Tamarack, has extensive clinical experience in pressure sores and diabetic foot ulcers. He's also had extensive experience working with different techniques and materials for offloading. So this is the guy that made Engo and ShearBan. He summarised the research literature in this way. The research literature clearly indicates that the shear component of the contact loading is the direct culprit. Pressure is not the direct cause of repetitive loading skin trauma, i.e. hotspots, blisters, abrasions, and ulcers. Pressure is a factor that enables the friction or shear to reach traumatic levels. And that is a really good article to read if you want to learn more about shear. It's one of the best ones that I've come across. Okay, the principles of shear offloading at high-risk locations. Shear offloading should generally be done at the same locations where pressure offloading is done, at sites with previous ulceration, callousing, and deformities. These are the sites that should be relatively easy for the practitioner to identify since they are the same ones where pressure offloading is traditionally done. How can friction and shear forces be offloaded? Friction and shear, like pressure, cannot be eliminated from the foot in the ambulatory person. In fact, friction is necessary for efficient gait, otherwise the foot would slide around inside the footwear too much. Thus, friction and shear, like pressure, need to be managed and relief needs to be targeted to high-risk locations. It's not the aim of ulcer management or blister management for instance, to reduce friction everywhere. It's actually necessary for the efficiencies of gait. The first step in offloading shear involves identification of areas of high potential shear on the foot. Those areas of high potential shear fit into three categories. These three categories are ones where pressure offloading has traditionally been done. Firstly, areas of previous ulceration are at high risk for re-ulceration. Murray and colleagues found that the relative risk of an ulcer developing at a site of previous ulceration was 57 compared to a relative risk of 5 for an area of elevated pressure. Secondly, areas of callousing are at high risk for ulceration or re-ulceration. Callus formation precedes ulcer formation in over 82% of patients with diabetic foot ulcers. Murray and co-workers reported callus formation to be highly predictive of diabetic ulcer generation, second only to previous ulceration. And lastly, areas of deformities may be at high risk. So hammer toes, claw toes, prominent metatarsal heads, Charcot deformities. These are the locations of likely ulceration. So we're looking at identifying these high risk areas. Pretty easy for us because we know this because we're always trying to offload pressure. In theory, there are a variety of ways to make a contact surface, that is footwear, orthosis, etc., more slippery. Many solutions have been tried in the past, however, each presents challenges. Once an area of concern on the foot has been identified, how is it managed? The solution is grounded in the research of Paul Naylor in the 1950s, where he found that the coefficient of friction between the skin and the rubbing agent affects the number of rubs which the epidermis can withstand before it ruptures. By lowering the coefficient of friction between the epidermis and contact surfaces, the epidermis can withstand more rubs, i.e., we can walk further, take more steps without tissue breakdown. The coefficient of friction of a surface in contact with the skin can be lowered by making the interface between the skin and the contact surface more slippery. Lubricating agents have been used to increase the slipperiness of materials at an interface in order to reduce friction and shear forces. These include oils, silicons, and powders. In these studies, the agents initially decreased the coefficient of the interface with the skin, but once the lubricants were absorbed or worn away, the coefficient of friction levels spiked. Therefore, lubricating agents ultimately can be counterproductive. And that's not to mention that lubricants will often negatively impact the adhesion of dressings. And also, we don't really want lubricants working their way through dressings into the wound. Materials such as moleskin have been used for a long time. The benefit of moleskin, however, is a tactile illusion. It looks nice and cushy, but it doesn't actually reduce the coefficient of friction. It's actually quite high when paired with a cotton sock. Socks can be made of materials that provide some relief from shear. The best that I know of in terms of blister management is armor skin socks. They're very slippery. However, the relief is not targeted. Friction is not always bad, and in fact, it's necessary for efficient ambulation, and one would argue, particularly when balance is less than ideal. Socks and insoles that reduce friction over large areas may also reduce gait efficiency because the entire foot can slip slightly with each step. Moreover, the effect can be to transfer loading to non-plantar skin, which is less suitable than plantar skin at handling gait-related loading. What has been needed, therefore, is a material that provides substantial reductions in coefficient of friction to targeted locations throughout the gait cycle, through a high number of cycles, and under differing environmental conditions. And that's where and why ShearBan came about. So ShearBan is a patented patch with 3 principal layers. It's got the low friction outer layer, which is PTFE or polytetrafluoroethylene, and that's stuck to backing with a pressure sensitive adhesive. Based on extensive research and testing, Tamarack selected a particular formulation of PTFE that is supple, durable, and very slippery. In addition, Tamarack uses special proprietary techniques to bond. ShearBan comes in a variety of forms, small ovals or large rectangles that can be cut to size. These days it only comes in the sheets, and because Engo's is the exact same product, the patches are now just in the Engo brand. ShearBan is applied to the inside surfaces of footwear or other pieces of equipment at the contact point where calluses, blisters, and ultimately ulcers have formed or might form, reducing shear forces by as much as 50%. Orthotists and prosthetists have used ShearBan for years to prevent hot spots on the residual limbs of amputees or a point of rubbing between an orthosis and extremity. Professional and extreme athletes have long used Engo to manage friction blisters. Now increasingly healthcare professionals are using ShearBan to prevent and manage diabetic foot ulcers. I would say this hasn't really caught on. So back in 2010 till now, I'm not sure it's really gained the traction, pardon the pun, that it probably should. But anyway, that's just me. Okay, let's have a look at the features and benefits of ShearBan. So ShearBan has an ultra low friction surface. So that neutralizes shear, the primary cause of calluses and foot ulcers, by forming a low coefficient of friction interface between the sock and the skin, the sock and the shoe, sorry. And it maintains a low coefficient of friction in moist conditions. Now, the diabetic foot may not sweat that much, like when we're dealing with athletic foot blisters, but we do get moisture from wounds. So it's good to know that even in high moisture environments, it keeps the coefficient of friction relatively low. Now, this image isn't in the white paper, but I added, this is from that 2006 paper from Carlson. The bottom blue one is PTFE or ShearBan. So the x-axis is percentage of water by weight, so from 0 to 100%. And you can see that the coefficient of friction is pretty level the whole way through. Plastozote is the green one. So it's relatively, it increases a little, but not much. So it's, I guess, relatively unaffected by moisture. However, the coefficient of friction to start with is about twice that of the PTFE. Poron or PPT is the yellow one. So the coefficient of friction increases markedly initially, and then kind of levels off at about 30% moisture, and then starts to increase again at about 80%. And Spenco starts at about 0.45 and ends up at about 0.75. So Spenco has a relatively high coefficient of friction. Now, it's worth noting there's an evidence base. There's not an evidence base for a lot of blister prevention strategies, but there is an evidence base for Spenco. So lowering the coefficient of friction is not the only way that we can combat ulcers and blisters. Spenco does it by absorbing shear load. So even though it's got a relatively high coefficient of friction, it certainly has a shear absorbing mechanism. And imagine if you could potentially add the PTFE to the Spenco. So you've got shear absorption and you've got low coefficient of friction. Then add your pressure deflection, and then you've got pressure management as well. ShearBan is thin. It does not interfere with foot function, shoe fit, or pressure relief modalities. It measures 0.38 of a millimeter. So they're very thin, very, very thin, which the fact that they last so long is brilliant, particularly with athletic foot blisters. You really don't want to add more bulk to the area. And really the same could be said for ulcer management. ShearBan is supple to a point. It conforms to contours, I would say, to a degree, or depressions, and it's easy to work with. If you're using ShearBan or Ango patches with pressure deflection, it's really a good idea to warm the patch up with a heat gun. That increases its conformability a little. Where there is significant pressure deflection, I like to make the patch quite a bit bigger than it ideally, well, not ideally, than it really needs to be, because as the patch is pushed down by the prominent joint, let's say a metatarsal head, it kind of puckers the patch around the outside. And I don't really want that puckering to be anywhere near an at-risk area. That's the only thing I find. So, if I think that I could get away with a small oval, I'd generally go to a large oval, or I'd cut out a bit of ShearBan to make it whatever size I need it to be. And the heating of the patch also helps with adhesion, which is really important for the outer edges that tend to pucker. If you get a really good initial adhesion, that puckering will be minimized as well. So that's one thing I will add just from my own experience. ShearBan applies to footwear, not the skin. So this reduces or negates actually any skin irritation, because there is no contact with the skin. Having said that, there can be direct contact with the skin, but I'm assuming that in most situations we wear socks, so therefore there is no direct contact with the skin. It works well with a variety of wound dressings, treatment modalities, and it's long lasting. It's easy to work with. You peel the backing back and it's easy to use. And it comes in different forms. That is the Engo patches, which are the ovals and the rectangles and the heel packs, or the sheets that you can cut to size. And durability, multi-week, most often longer. Protection. So I use ShearBan quite a bit with, like, I don't have a high risk clinic by any stretch of the imagination, but where anyone has had an ulcer and we're trying to prevent re-ulceration, even if we don't have that much pressure deflection, let's say, you know, they've got scarring, let's say they've had an ulcer, they're not diabetic or they're not at really much risk, but they've had this lesion. If I just want to reduce shear forces in that area, it can be just as easy as an Engo patch on some Spenco. I mean, generally I'll use Spenco just for a bit of shear absorption and cushioning, and then put an Engo patch on the top. So I use it a lot for that. Another application that I use it for is painful calluses, and I'm thinking mainly in terms of people with adult acquired flat foot deformity and calluses, painful calluses, and even blisters under the callus at the medial first MPJ and sometimes hallux as well. It will just, one lady comes to mind because she comes from Perth to the holiday down here, and she sees me for this in particular, and she just brings all her shoes, and I add the Engo patches. For some reason she can't bring herself to do it herself, but that's fine. And she was really held back by these painful calluses, and they would occasionally blister, but generally they wouldn't because she just couldn't do the activity. It was too painful. And the Engo patches have literally been life-changing in terms of taking the pain out of that callus at the medial first MPJ. So painful calluses, definitely use it for that as well as blisters and any ulcers in terms of prevention. And treatment, of course. Okay, in conclusion, shear is increasingly recognised as the mechanical force most directly implicated in causing diabetic foot ulcers. ShearBan is a patented interface material used by clinicians and footwear specialists to prevent and treat diabetic foot ulcers. ShearBan works by offloading shear forces at areas of concern targeted by practitioners. ShearBan complements current pressure offloading techniques. It can reduce friction and shear by as much as 50%. And I'm not going to go through the case studies, but I'm going to forward everyone that's registered for this straight after this meeting. I'm going to send you an email with the download, and if you're watching the replay, then I'll have the download available with the replay. So is there any questions in terms of the ShearBan before I get onto the Q&A?
No.
No? Okay. Thanks, Marianne. All right, we had 3 questions. Emily asks, how does the blister pad, that is ShearBan, offload significant pressure? The answer is it doesn't. It doesn't do anything to pressure. It literally reduces the coefficient of friction, and that's how it reduces friction force. Separately, if you had pressure deflection, that would also help to reduce friction force. So it is literally making it more slippery. Catherine asks, what are the top 3 prevention techniques for long distance events? I assume we're talking about blisters now. I like to answer it this way. It really depends on the anatomical location, but I know that you don't want to hear that. So, Catherine, I'll be a bit more helpful. If I had to distill the way that I approach blister management into very short and sharp sort of description, it would be I'd use gel toe protectors for the majority of toe blisters and Engo patches for everything else. But I'm always looking for something that is specific to that site, and that is generally the bone movement component. So I'm generally looking for what are these bones doing? So like for a high arch foot that flattens significantly on weight bearing, I'm thinking about as those bones like the first met cuneiform and cuneiform navicular joint become weight bearing, and that pressure holds the skin surface stationary while the bones continue to move forward as the arch flattens. I'm thinking about that bone movement. How can I impact that bone movement? Of course, that's probably going to be with an orthotic, maybe calf stretches as well, heel lifts, shoes with a heel height differential, that kind of thing. Compare that to, let's say, blisters around or under the toenail. So that is generally caused by the toenail taking weight-bearing force. So it's just pushing the nail back with each step that you take. So, of course, I want to straighten that toe out if I can, or at least reduce the pressure on the apex of that toe. So always think about the anatomical location and what is specifically going on there in terms of bone movement. Now, Catherine, if you have a patient that's come in and said that they've got this long distance walking or running event that's coming up and they want to know how to prevent blisters, the way you would go about that within your consultation is this. You'd predict their likely blister locations. So you would figure that out by understanding their blister history. Anywhere they've had a blister before is where they're more than likely to get another blister. Just expect that blister to happen. Determine what the best prevention or preventions are for that location and implement them before the race, before, like in training even, so it can be tested so it's not brand new on race day. Also predict blisters where there are calluses. So calluses are a sign. They're not causative of blisters per se. They're a sign that there is relatively high shear load at that location just in normal daily activities. So when our activity level increases all of a sudden, the skin won't have time to adapt. It will blister instead. So expect to get blisters there, and find out the best prevention for that location and implement that before you even start. And thirdly, any structural or functional issues that you can figure out. So let's say they haven't been particularly active, they don't even have a blister history, they don't actually have any calluses, but it's all a bit of an unknown. You'd be looking for things like hammer toes or, prominent metatarsal heads, that kind of thing. So once you've determined their likely blister areas, and what you would do is you would figure out the best prevention for that anatomical location and have it in place during training, not just on race day, and not even in a blister kit ready to apply, because generally it's hard to stop, or people procrastinate and don't stop because thinking, this is just going to go away. What am I going to do? Where's my blister kit? Have I got this? How do I even use that? And then by then it's too late. So have it in place before you even start. And while you're thinking about the best preventions, you can then nuance that decision to the activity. So rather than saying what's the best prevention for long distance walking events or long distance running events, firstly, hone in on the anatomical location, start with those best preventions for the anatomical location, and then nuance it for the activity. So maybe the shoes, is swelling going to be a component? What's the climate going to be? Nuance it that way, rather than starting at the activity and then trying to go from there, because it's much less effective. Anthony asked, what's the short-term assistance for painful blisters, permitting the sufferer to continue activities? Anthony, the answer is not just first aid. So first aid is important, i.e. betadine and a Band-Aid in its simplest form. That's important to prevent infection if the blister is open. However, if you want meaningful blister treatment, and that is blister treatment that means that the blister is going to hurt less, it's going to start healing rather than getting worse as activity continues, you need to implement the prevention. The prevention is the thing that negates the blister causing forces. Without that, it's really just first aid. So that's it, guys.